Hello everybody, my name is Akanksha Malhotra and my project partner name is Isaac Hammis, and we are here to present our work on the topic sentiment analysis using cloud technologies. So starting off with what is sentiment analysis? Sentiment analysis is an application of natural language processing, which is also known as opinion mining. What it basically does is takes a text and tells whether the polarity of that text is positive, neutral, or negative. And that text can be anything. It can be a whole document, a paragraph, a sentence, or a clause. So moving forward, the services that we build for our project, one is sentiment analysis. We built our own sentiment analysis model, which achieved accuracy of 80.22%. Um, and we use features like TF-IDF and the emoticons that are present in the document. Uh, for that, we build a term document matrix for emoticons. The other feature service that we built was of topic identification. What it does, it identifies the topic within the tweet, and that can be further used for detailed analysis, such as like a percentage of negative or positive tweets, what the model has already identified for that particular topic. And also what it can be used is for like the intent analysis for in future. And for this, features that were used were hashtag, retweet handle, mentions, named entity, and LDA topic model that we built on our own. Our sentiment analysis model only predicts positive and negative sentiments. It does not predict neutral sentiments. Um, so the third service that we built was feedback service. So what we want our sentiment analysis model is to learn with whenever it is wrong. So we ask, the user can give a feedback if he or she thinks that the sentiment of the predicted sentiment of the text is not correct. And how we do is like we store our model in a Redis database, and Redis database has a functionality called watch functionality, which actually what watch does is it watches the key of the model, and while it's watching, if any other worker updates that model, then whatever transactions this particular worker who was watching the key is doing, it will be all cancelled, and this worker needs to download that particular model which is updated by other worker, and then redo its computation. So what this functionality do is to keep the model consistent and do not override and helps in not overwriting the model, the updates of other workers on the model. Moving on, my project partner will show the go through architectural flow.
Yeah, so we built our project primarily using Kubernetes with Docker images as containers. So the general flow of our service is documents come into the front end. The REST API sends the documents to the workers through RabbitMQ to balance the workload. The workers process the documents, giving them topic labels and identifying them as positive or negative sentiment. And then the sentiment, along with the original document, is stored in the MySQL database, and the Redis database stores the topics identified by a unique hash that's also present in the MySQL database. So while the worker's processing the documents and sending them off to the databases, the REST API is waiting for the database to be updated with the hash of that document. When it's updated, it then sends the analysis back to the front end to present to the user. And then from there, the user can say that the analysis is incorrect. And if it says it's incorrect, you can put in the correct sentiment that will then be sent back to the Redis sentiment analysis model and be updated so the workers will have a more accurate model in the future. So now I'm going to go ahead and demonstrate our project with a few tweets. So here we go. All right, so I'll start with a tweet that's clearly negative. See if it picks out. And it looks like Iran should also be a topic probably, and it did pull those out, but I guess it's being negative. So I'll enter another one. And this is clearly a positive tweet with saying that it loves the Kindle 2. Let's see. And it gave it positive, which is good. And this tweet could be a little bit more confusing for sentiment analysis because it uses a negative word but with a positive connotation. So we'll see if it's able to guess this one correctly. And it did. So that is a good sign that our model's working well. Then here's another one using basically the same word, but in a negative context. And let's see if that one works. And it gave it a negative, as it should. So then the last one is something that our model struggles with, and it's when it uses not in front of a good word. So it says Kindle 2 was not the best use of my money. So that's pretty fairly negative, but it said it was positive. So and go ahead and say that the analysis is incorrect, say that it should have been negative, and then submit feedback. And thank you for your feedback. So it worked as it should have. And I guess that's all. Thank you for listening to our project video.